Hi, I'm Ahmed Daud, and in this session we will discuss the questions that was raised in the last session. First, how we can calculate some particular score for an individual class in the case of multi-classification. And second question was how micro average score is equal to simple accuracy. And third, what are the intuitions behind the averaging techniques, micro, macro, and weighted? First of all, this is a simple matrix, which is confusion matrix for the binary case. And first, we will see the intuitions behind precision and recall that you already have in your mind. So, just for the sake of review, let's say if I will consider this confusion matrix. So, if I will ask what is recall, so recall will become here how many positive samples are correctly classified. Okay, so these are the total positive samples we have, false negative plus true positive. So how many positive samples are correctly classified? So true positive divided by all the positive samples. So this can be called as a recall for the positive class. Okay, so in the same way, if we will follow the same intuition, we can also calculate the recall for a individual class in the case of multi-classification. Let's say here, what is the recall of ideal class? Let's say this is the ideal class. So I will ask how many ideal samples are correctly classified. So you will first ask how many total ideal samples we are having in our actual dataset, which are 0 plus 2 3 4 plus 4 8 9 8 plus 2 5 6 and 4 8 9 8 are correctly classified. In the same way, you can calculate for the good class, for the fair class, and for the premium class. Okay, and you can see here if you want to see the recall for the fair class. So how many fair samples are correctly classified? So total samples, fair samples were 0 plus 147 plus 162 plus 93, and 0 fair sample is correctly classified. In the same way, you can calculate for this and for this. Okay, if we will understand now the intuition of precision. Okay, if I will ask you what is precision, you will simply say how many positive predictions done by our classifier or model are correct. Okay, so first you will see how many positive predictions done by our model. You will go in that way. These are the actual positive predictions you know from here. So how many positive predictions done by our model? True positive plus false positive. So out of all positive predictions, how many are correct? Okay, so this will be a percentage. This will be a percentage precision you can call as it in that way, that what is the percent, what is the probability that positive prediction done by our model is correct. Okay, let's say at some place 80% we were having precision. It means there is 80% chance if our model will predict positive class, then it will be correct. 80% chances of the correct positive prediction done by our model. In that way, you can interpret that. Okay, for the sake of calculation, you can go in the same way like we go for the case of recalls. So if I want to calculate precision for the ideal class, simply go here. How many total ideal predictions done by our model? 731 plus 4898 plus 1877 plus 162, and how many are correctly predicted? 4898. Okay, so this will be your precision for the ideal class. In the same way, you can calculate for the zero class, for the good class, and for the premium class. Okay, now you got an idea. You can calculate how you can calculate precision or recall for an individual class in multi-class case. Okay, you can directly can calculate by using the intuition that you already know. Okay, now one important concept is here. Here you are saying that in the case of multi-class, we are after calculating the score for each class, we go towards the average technique. Then we will usually take an average of all the precisions. Okay, all the precisions. Let's say we are having here one, two, three, four precisions. We will take average of all the precision if we have selected precision as our good metric. So we will take an average. So you are here visualizing that here average precision is scattering all the cells of the confusion matrix in case of multi-class. Okay, because you are calculating the precision with respect to each class. But usually in the case of a binding classification, we are just calculating the precision with respect to the one class. And I have told you that reason multiple times because in the case of binary classification, we already have insight regarding the frequency of positives and negatives. Also, we know there are just two errors. Okay, so here we can say we also can say in that way uh, that if we are curious about the precision of ideal class, if we have we selected that ideal class about ideal class we are curious, then we have figured out that we are curious about uh, the error that is not ideal as ideal. Okay, if model will predict some sample which is not ideal as ideal, this error is bad for us. So we say that we want high precision regarding ideal class and also good precisions regarding other classes. Okay, so that we can cover all the errors, all the confusion matrix in the case of multi-class. In the case of binary, we usually follow that method in that way. Uh, we say that we want, let's say we have figured out we are curious about the false positive errors. Then we selected precision as our measure in the case of binary classification. So we usually say that we want high precision. We want such a model which has high precision and also good recall. Why also good recall? So that we don't want that such type of model which has very less false positive but very high true positives. Oh, sorry, I am going wrong. Very high false negatives. Okay. Here we are saying in the case of binary classification, we say that we want high precision and good recall. If you have selected recall as a best measure, you simply can say, I want such type of model which has high recall and also good precision. But in the case of multi-class, we usually say in that way, I want high precision for the ideal class, but also good precision for the other classes, for the sake of covering all the errors for all the uh, classes. Okay, so that is all about how you can calculate the scores for the individual classes, and there is a little bit individual uh, difference in between binary and multi-class case, and that's why saying that there is a little bit difference in way of thinking in both cases, in binary classification and in multi-class classification. Okay, second way that I want to tell you here is this one. Okay, so we can also calculate our scores directly from confusion matrix, multi-class confusion matrix, and there is another way that first we will compute binary confusion matrix from a multi-class confusion matrix, then we can calculate procedure recall and score of our interest. Let's say I want to calculate the scores for the good class. Okay, so first I have to generate a confusion matrix of good class. So here I will generate confusion matrix for a good class. So here I have considered like a good and not good, or you can other words you can say for a while it is positive and it is negative. And here it is negative and it is positive. Okay, for a while you can consider in that way. So how you can draw confusion matrix for our from multi-class for just a good class confusion matrix, okay, or confusion matrix for just a good class. So if I will zoom out here and okay, so first of all, how many predictions done our model as good and they are also good. Okay, so 1505 you have drawn from here. How many your model has done prediction as good and they are also good. So you can see here from 1505. Second one, how many your model has done predictions as positive but they are actually false. So your model has predicted some samples as good. Oh, sorry, I have made this one wrong. Sorry for that. This should be here. Yeah. How many your model has predicted samples as good, but these are actually not. So this one, this one, and this one. Sum of these values will be 1422 plus 234 plus 147. Okay, so this will be this cell. Now, how many predictions or what are the predictions that your model has predicted as not good and these are actually good? So our model has predicted this sample as not good, not good, not good, and these are actually good. So you can also compute this cell. Okay, in that way, 0 plus 1877 plus 865. Okay, now the last one will be how many samples your model has predicted as not good and these are actually not good. So from here you can say your model has predicted this sample as not good and actually not good, not good, not good, not good, and these are actually not good, not good, not good, not good, not good. Okay, uh, this is also here. How I can do this? So I can black. Yeah. Okay, this one. Uh, okay, so these white circles will become if you will take a sum of that 0 plus 162 plus 93 plus 0 plus 4898 plus 256 plus 0 plus 4731 plus 1295. Okay, these are the samples that your model has predicted as not good and these are actually not good. Okay, these are actually not good. Okay, in this way, first you can compute a confusion matrix for a individual class. Then simply in the same way, you can calculate the precision, recall, and F1 score. Like precision, if I have to compute precision for the good class from that matrix. So simply it will be how many predictions done our model as good 1505 plus 1803, and how many are true. Okay, these are the two 1505 and you can compute the precision in that way. In the same way you can calculate the recall and in the same way calculate F1 score. So this can be a second method that you can follow. Okay, although these all the stuff can be easily done by the libraries in the code, but here is not the way of explaining or the reason of explaining is to compute them. The reason of explaining how they compute them so that you will be have better understanding when you are doing some selecting some performance measure. You have some good intuitions behind each measure, each way of calculation. So now, second part will be what are the intuitions behind each averaging technique. Okay. So first of all, macro averaging. Simple. Compute performance for each class. Let's say you have selected performance, recall performance. Okay. So compute performance for each class, then take an average. It's quite simple. Calculate recall for each class, ideal, premium, good, fair, and then sum all the values and divide by number of classes which is 4. So this will be your macro average recall. Macro average recall, or you can say also sometimes balanced recall. Okay, and people also sometimes using this as a balanced accuracy. Okay, they are using the name for balanced recall as a balanced accuracy. Okay, so how in that way you can calculate macro average. Now we will go towards the micro average, and in that part we will understand why micro averaging score are equal to simple accuracy. We will also understand that. Okay, how first of all how micro average actually calculated. First you have to compute confusion matrix for all the classes individually. Okay, you are having a big confusion matrix which is 4 by 4 confusion matrix. Okay, so from this confusion matrix you have to compute a confusion matrix for each class. Okay, then what you have to do, each class, now you have to compute true positives, false positives, and false negatives. These three measures we usually use in the recall, precision, and F1 case. Okay, so you have to compute total true positives. So here in the case of premium, true positives are this. In the case of ideal, true positives are 4898. In the case of good, 1505. In the case of fair, 0. So you will add all of them, and you will get total true positives. Okay, so this will become total true positive here, 7698. This is in the same way you can compute false negatives for each. So false negatives, uh, model has predicted this as premium but it is false. Sorry, I'm going wrong here. Model has predicted this as a not premium, means this as a negative but it is actually premium, so it can be false negative here with respect to premium class. So this is a false negative, this is false negative, this is false negative, some of them will be overall false negative 5787. In the same way, you can compute for the false positives. These are the false positives, and total false positives will become this one. Okay, so you have computed all the true positive, false negative that we usually use in these three measures. Now you can compute recall, precision, and F1 score for micro average. Okay, so micro recall will be how many? This is true positive divided by true positive plus false negative. True positive 7698 divided by 7698 plus 5787, which is false negative. So this is here. In the same way, you can calculate micro precision, and it is again giving the same score. Micro F1 score, it is again giving the same score because precision and recall are both are same. So average of both will be same, 0.57. Now these are measures are giving the same score. Now we will compute accuracy of our. Here we will calculate accuracy from multi-class confusion matrix. So sum of all the true prediction divided by all the samples that we have used for predictions. So 0 plus 15054 plus 48 plus 1295 divided by 13485, and accuracy will be here 0.57. And you got an idea technically when you calculate micro average precision, micro average recall, micro average F1 are giving the same score as accuracy. Okay, so that's why these are actually the same. Measuring micro average scores is actually the same as the score of simple accuracy. So that's why in the last session I have calculated accuracy in the explanation of micro average computation. Okay, so here now we will discuss some points. Micro average holds the same property as accuracy, have global metric, not good for measure when classes are uh, imbalanced. Okay, so now we will see a difference between micro average and macro average. So micro average here give equal weight to each class, each sample. Micro average give equal weight to each sample, but macro average give equal weight to each category, or you can say each class. Okay, so that's why actually the reason of a micro average and macro average. Now we will go back and I will give you a more good understanding. Micro give equal weight to each sample, macro give equal weight to each class. Okay, so here we will see how they are giving equal weights with respect to sample. And okay, here you can see my macro first compute score for each class, then take an average. Okay, each class it compute the score for each class. Okay, and then compute the average by summing them divided by 4. Means they are giving equal importance to score of each class in the case of macro. Okay, macro following with respect to classes, score of the classes. But micro is not relying on the scores of classes. It also further going downward from class level to downward towards the sample level. That's why from the confusion matrix, it is binary confusion matrix. It has compared to from the class confusion matrix, and then again go downward towards the total predictions, total true prediction, total false predictions. Okay, so it is going towards the samples. It is going towards to give equal weight to each sample instead of giving equal weight to the each class. So that's why micro average give equal weight to each sample, macro give equal weight to each class. Another way here, you can see false negatives and false positives are equal here. What is the reason? Okay, so I will give you the reason from the binary classification. It can also give you the idea of uh, like why micro is same as accuracy. Okay, so let's say I will not explain the way that we usually do. Here I will say, let's say this is a confusion matrix for binary case, and we usually having predictions on that side. Let's say this is predictions. Okay, and these are the actuals. And instead of giving positive negative here, I will say that this is class A, class B. Okay, so this is class A, this is class B. Okay, so this is the confusion matrix. And here I will give the number. This is cell number 1, cell number 2, cell number 3, cell number 4. Okay, so now if consider class A as a positive class. Okay, so I will make the replica of both so that it will be easy for you. Okay, and I will give the different color to this one. Okay, so if you will consider class A as positive class for a while, let's say. So if your model has predicted class A, it means positive, and actual is also class A, it is true positive. Model has predicted class B, it means negative, and it is false. Model has predicted class B, and it is also true. Model has predicted class A, means positive, and it is false. So in the case of confusion matrix, we usually consider these three measures. Understand these three measures. So this is the main false negative and false positive. If I will say that with respect to class A, with respect to class A, your false negative and your false positive. False negative is in cell number 2, cell number 2, and false positives are lying in the cell number 3. Okay, okay. So now if I will ask you here, let's say class B is a positive class for a while. So your model has done these are as a positive prediction, and this as a negative prediction, and this is true prediction, and this is also true prediction, others are false. Okay, so with respect to class B, your false positives are and your false negatives are here. So false positives are lying in the cell number 2 and lying false negative lying in the cell number 3. Okay, so now in the same way that we did in the micro averaging technique, we have added first we have a compute confusion matrix for each class, then we have added their false positives of each class and false negatives of each class, and then we find out that false total false negatives and total false positives are actually the same. Here you will see. Now compute add false negatives of class A and class B. So false negative of class A are actually cell number 2 and plus false negative of class A. These are the actually false negative if I will write here in that. False negative cell number 2 plus in the case of B, it is cell number 3. Okay, so if I will compute false positive, total false positive for both classes, in the case of class B, total false positives are lying in the cell number 2, and in the case of class A, false positive lying in the cell number 3. Okay, so you are getting the idea here that when you will calculate total false negatives for all the classes or total false positives with respect to all the classes, actually you are getting the same value. Okay, you are getting the same value means how many total false predictions done by your model. Okay, or in other words you can say here that if you have classes, the false negative of class A, here in binary case false negative of class A is actually the false positive of class B. From here you can see from the cells you can get an idea. False negative of class A, it's actually the false positive of class B. Okay, so false negative and false positives, it's actually just with respect to the considering a class. When you will add all the false negatives or with respect to each class, you are actually getting the same value that adding all the false positive of each class. Okay, means how many false predictions done by your model. Okay, so how many false prediction done by your model is this one, and divide by true prediction done by model plus false prediction done by model, that is actually accuracy, and in the case of micro average recall precision, f1 score giving the same score. Okay, and why micro do that way? Because micro give equal weight to each sample. It goes downward from classes to the towards the part samples, and it actually see each sample, either each sample is truly predicted or false predicted. Okay, so that's why micro average give equal weight, macro give equal weight to each class. So that's why you can say macro is upper level, giving equal weight to each classes. Micro is lower level, giving equal weight to each sample. So micro average is actually the same as accuracy. I hope you got an idea. Now, micro average, it's same the accuracy, so holding the same properties. So we will discuss their properties also. What is actually accuracy? Accuracy, we usually say that if some model has 80% accuracy, we will say that if any sample, any individual sample you will pass to that model will give you the there is 80% chance that model will correctly predict that sample. Okay, you are going to with respect to individual sample. So accuracy is actually the probability. Accuracy covering the single individuals, going with respect to individuals, not going with respect to the class. Now if your class distribution is the balance, if you have balanced data set, then all the classes will have equal number of samples. So if you will go towards to the way that giving equal weight to each sample, then overall classes will have equal number of samples and you are having good score for each class. But if you have imbalanced data set, either you are giving equal weight to each sample, but the class which has more samples will get more weight automatically. Okay. because you are calculating with respect to sample, you are not calculating with respect to class. So class with more frequency will get more weight in the case of accuracy. So if you have question that you can ask a question to yourself, am I interested in predicting the highest number of individuals in the right class without caring about the distribution, class distribution and other indicators? Okay, you are not caring about the classes, you are just caring about uh, that you have to predict highest number of samples, no matter which class to belong that sample. Okay, so if your aim is this one, then accuracy can be a good measure for you. Accuracy tends to hide strong classification errors for classes with few units. The reason is that accuracy gives more weight to the classes which has more frequencies. It is not possible to identify classes where algorithm is working worse. Uh, the same reason here, that if your there is a imbalanced data set, and imbalanced data set there is one class which has very less number of samples. When you will train a model on that type of imbalanced data set, you will have such type of imbalanced model, unbalanced model, which will have very less surety to predict that class that is in minority during its training process. So that's why uh, your predictions also will have less number of the samples belonging to the minority class. And there can be a chance that it can work bad on that class. It can be chance, but when you will use accuracy as a measure, accuracy will calculate irrespective of the classes, and it will give more weight to the classes which has more samples that we have used as a prediction. So which has more samples, and due to more frequency of samples belonging to some particular class, that class will have more weight. And if that class will be good, giving a good score, or the samples of that class are correctly predicting, then overall accuracy will be good irrespective of the bad predictions of the classes which has very low number of samples. Okay, so on the other hand, it's quite a good measure in the sense of intuition, in the sense of interpretation. Okay. And another way here, I just want to say you here, we usually are having like this. Let's say you have total data set. Okay, I just want to give a recap. I know you already know about this. We split our data set into training part and testing part. Okay, in the case of classification problem, let's say here you have 100 samples belonging to class A, and let's say 50 samples belonging to class B, and let's say 10 samples belonging to class C. So how you we this is total data set that we usually we have. If we will split that data set into training and testing part, we say that 30% samples should be in testing part so that we can evaluate our model, and 70% samples should be in the training part. So 70% of class A will be 70 sample belonging class A. 70% sample of class B will be about like 35 samples belonging to class B will we have, and 7 samples belonging to C. In the same way, you will have 30 samples for A, 15 samples for B, and 3 samples for C in the testing data set. Okay, so usually you follow that method and you train your model on this. Okay, and test your model on this, and it will give some prediction that you usually compare with your true values. Okay, so here you are training the model on the same type of imbalanced data set, and you are have to classify your model on the same type of data set so that you can actually evaluate how what type of model behavior is. Okay, so that's why sometimes I was saying that a training data set is imbalanced and testing data set imbalanced is actually because of our overall actual data set is imbalanced. Okay, and I hope you are already familiar with that scenario. It's pretty much easy that you have to just split your data set into training and testing part by giving it equal weight to by splitting equal percentage of samples in training and testing part with respect to each class. Okay, anyhow, we are talking about micro average, which is actually accuracy. Now we will go back and we will see macro average. So here, macro average. So macro average, people are sometimes using macro average recall as a balanced accuracy, and we can also say that macro average recall as balanced recall, and macro average precision as balanced precision, and macro average F1 as a balanced F1 score. Now here the question in the case of macro average that we have seen, that I have told you that each class have same weight during macro averaging. Why they have same weight we will discuss here, and some also important points. Okay, so first of all, let's say for a while consider that you are interested in calculating macro average recall. Okay, and we will follow that intuition in the explanation of that macro averaging. So what actually recall? If I will ask you a recall of a class, some particular class, some individual class, so you will say uh, how what percentage chance of, or you can say if class A, so of how many number, or we usually have scores in the form of percentages. So we can say that what percent chance that class A, samples of class A are correctly predicted by our model. Okay, or in other words here, it's very formal way of explanation. How likely will an individual of that class be classified correctly? So this is recall. So when you will take an average of that concept for all, this is recall of one class. When you will calculate recall of all the classes and take an average, it means you are calculating balanced recall, providing an average measure of that concept, the concept of recall. Okay, and in the same way, if you are calculating precision, so you are taking the average of concept of precisions for each class. As uh, the macro average give the equal weight to each class, so it compute all the scores then take an average. Okay, no matter which class have low frequency or which class have high frequency, it is just have to calculate all the scores separately then take an average. Now macro average and micro average, which is actually accuracy, uh, converge to the same score if we have balanced data set, and it is pretty much easy that if you have balanced data set, your all scores are equal. So if you have balanced data set, your if you will calculate recall for us individual class or individual class, each will give same type of two predictions, and average of same type of two predictions will be actually the same as the accuracy and same score. So that's why in the case of balanced data set, your accuracy and your macro average recall are the same, or macro average recall precision, whatever macro average score will be equal to the accuracy. Okay, so now here is the point. If some class is having less frequency in the actual data set, and when you will give more equal weight to each class irrespective of their frequencies, then the class that have low frequency in the actual data set will have more weight than their proportion of samples in the actual data set in the overall score, in the overall macro average, because you are giving equal weight to each class irrespective of their frequencies. Okay, so these are actually the same stuff that I same like just take an average and divide by the number of classes. Same technique, same formula, but way of thinking, way of analyzing the scores are different. You can visualize your score from this angle, from this angle, from behind. Okay, so actually I am talking all the I am repeating my discussion multiple time, but each time I am trying to show you these measures from different angles. Okay, so here balance score can be a perk and can be a drawback. How it can be a perk? If you are interested in having good prediction on all the classes, also for the underrepresented classes, or also classes which has less samples, or also classes which has minority number of samples in the actual data set. If you are interested to have good prediction regarding all the classes, then balance score can be a good for you. But If you care more about the good prediction of entire dataset, then you should have to think about, if you are thinking in the way of whole dataset, then which class have more samples, that should have more priority. The samples, the class which has less number of samples have should have less priority. And then there will be another type of average we should take. Macro average will be like a drawback there, okay, because it is uh, considering all the classes as same. So on the overall entire dataset, maybe it can give you some bad score, or less score compared to other scores. Okay, so accuracy cannot cut the bad performance on the minority classes, but macro average can catch the bad performance of the model on the minority classes, or classes which has less number of samples. So if you are interested in achieving good prediction also for rare classes, the information of balanced score, or you can say macro average score, guarantees the to spot possible predictive problems also for the underrepresented classes. Okay, so this was about the micro and macro. Till now, you got an idea how you can calculate the particular score for an individual class in the case of multi-class classification. Then you also get an idea how micro average actually giving micro average score, any type of score, recall, micro average f1, micro average precision, are actually giving the same as results as a simple accuracy. Okay, and you have seen a lot of intuitions behind that also, because micro average focusing on the true prediction of each sample, giving each sample equal weight. Then you have seen the difference between micro and macro. Micro give each sample equal weight, macro give uh, each class same weight. Now we will discuss the third averaging technique that we were talking about in the last session, which was weighted average score. Okay, before we can have a look how we can calculate weighted average score. Let's say we have to compute performance for each class, and we have selected performance is recall here. Now you just have to calculate the recall for each class, and then multiply their recall with their frequencies in actual data, and divide by total number of samples we have in actual data. That is actually weighted average recall, you can say. Okay, now we will go towards the intuition of weighted average recall. So what is actually weighted average recall? If I will say that it is holding goodness of both averaging techniques, micro averaging technique and macro averaging technique. In that way, because it is also considering the classes, because it is calculating the scores for each class, like macro considers, and it is also considering the frequency of the classes, like micro considers, or simple accuracy considers. Okay, simple accuracy automatically consider, but it you can think in that way, that accuracy formula is not defined for to consider the frequencies, but their nature is in this way that they are automatically considering the frequency during the calculation. But Mac weighted average formula is designed in the same way. It consider frequencies during its formula, during its calculations. So that's why it holds the goodness of both micro and macro scores. Okay, in the same way, if in the case of macro average, you are calculating macro average, if some class have very less number of samples, no matter, you will calculate the score for that class also, and also for the other classes. Then by giving equal weight to each class, you are just taking an average. Okay, then there can be a chance the class which has low frequency will have less score because of less surety by your model. Okay, so i- the class which has less score can dirty your or can decrease or penalize the overall score. But in the case of average, weighted average, actually control the score by their frequencies. So the average of recall is no longer dated by low frequency classes. Now, uh, I have discussed that also. So this ensures to obtain a reliable value of overall performance on the data set. Okay, and you can also interpret this metric as a probability of to correctly predict a given unit. Even this formula of weighted average recall, or sorry, weighted average is different from the micro average. Okay, so for a simplicity, if I will go more in detail of weighted average, so weighted average also considering the frequencies by its formula. Okay, so that's why weighted average usually give similar scores or scores near to the accuracy. Okay, the reason is that it is also considering frequencies, and that's the reason that weighted average recall is actually equal to the simple accuracy. Okay, now you will get surprised that there is another score which is also equal to the accuracy, so you will get an idea about that also. Weighted average recall, if I will use the pen, okay, weighted average recall, it's actually the same as frequency. How it is same? In the terms of interpretation, they are different. Accuracy go with respect to this sample weight, but weighted average go with respect to both frequencies of the classes and with respect to the classes. Interpretation are different, but give the same results. Okay, so we will see their results also, uh, and also their formulas also. In the case of accuracy, you simple have, in the case of accuracy, you are total number of true predictions and divide by the number or total number of samples that you have tried. Total number of samples that you have passed to the model for the sake of prediction. Okay, number of true prediction divided by total number of samples. This is actually accuracy. And you also have seen in the case of weighted average, you are dividing by total number of samples. Okay, in the denominator for both accuracy and weighted average are the same. Okay, so denominator are both are having same. So now we will focus on the numerator. So numerator of accuracy is like this: all correct predictions, or you can say all correct classifications. Okay, we have in the numerator of accuracy. But in the case of weighted average recall, we say that sum of correct classifications with respect to each class. And when you will calculate sum of correct classification with respect to each class, they actually become equal to the all correct classifications. Okay, let's say here you are computing this one is your confusion matrix, and you are here computing all correct predictions: 0 1 plus 1505 plus 4898 plus 1295, and this is, you have total 7698 correct classifications. So just divide by it number of total samples, you will get accuracy. And in the case of weighted average recall, first you will calculate recall for each class. Okay, so if I will use this one here, you will get more good idea here. Instead of this, I should copy this. uh, it should be here. Yeah, now if I will ask you what is the recall of fair class, you will calculate in that way how many true prediction out of our fair samples. So 0 divided by 402 samples. This is recall of F. fair class. In that way, recall of good class, recall of ideal class, recall of premium class, and then you have to multiply their frequencies in actual data set. Frequencies there in actual data set. And here you are getting the point that you are uh, subtracting your frequency, your uh, frequencies are cutting off the denominators here, and you are actually getting the scores, true classification with respect to each class, and which when you will sum up that it will be equal 7698, same as the denominator of accuracy. Okay, so here is another interpretation you got here, that weighted average recall is actually same as the accuracy, but their interpretation, their intuition is different here. Now I will tell you, in the case of multi-class classification and imbalanced dataset, you can also use accuracy, but depending upon the situation, like depending on the situation, like you are curious about a class, let's say ideal class. You are curious about the ideal class, and in the way you are curious that no, you are curious about the error ideal as not ideal, means you want such type of classifier which should not predict ideal diamonds as premium or fair or not ideal diamonds, or sorry, good diamonds. Okay, if you have you are curious about this uh, ideal class, then and about this error, you have selected that for that case recall will be a good measure. Okay, now you want a recall. Now you want to highlight, means you want high recall of ID class and good recalls of other classes also. Okay, now how you can get a high recall of ID class in overall average? You will go towards the ID class and you will see what is the frequency of ID class in actual data set. So if I will go here and copy this one, here you are seeing that ID class has more samples compared to all other classes, means it has more frequency. So if you want to make your or design your performance measure in that way, that the recall of ID class should be prominent in overall average or in overall performance measure, then you can use here weighted average recall. Weighted average recall, because you have selected a recall as your best measure, and weighted average because you are saying that you want to make prominent the score of ideal class, and ideal class as a majority samples compared to all other samples of all other classes. So you can only make prominent score of ideal class by capturing the frequency of that class. So it will become weighted average recall, which is actually the same as accuracy. So in case of imbalance dataset and multi-classification problem, you can also use the accuracy, okay, by the interpretation of weighted average recall, and it depends upon the scenario, in which scenario you are using that score. Okay, so for now, in the next session, we will follow our uh, the flow that we are discussing, how we can select the scores, and then how we can select the best average for our scenario. Then we will discuss some we will continue that process of flow, type of flow chart, and then we will discuss some scenarios, how we can select some good performance measure, optimal performance measure according to our given scenario or according to our problem statement. And then after that session, we will go toward the part of code. Regarding code, it's very easy. Okay, now you got an idea. In the case of Binary classification, there is no way of using accuracy, because we always curious about the one class and one class always in minority. But in multi-class case, we don't know uh, about the accuracies, about the frequency of the classes. There can be a chance we maybe become more conscious about the class which has more frequency compared to other classes. There can be a chance like here. Okay, so in that type of cases, maybe we will use accuracy as our performance measure. So for now,